reflecting with constructions. Today we're going to do it on the coordinate plane. So how would we do this on a graph? The big idea from yesterday was that when we had a reflection, it was perpendicular and it was the same distance from the line of reflection, just to remember those things. So looking at the notes here, how would we do a reflection or flip over a line? Well, one thing to notice, the notation for a reflection is lowercase r, and then they write the line of reflection right next to it. So for example, this would be a reflection over the x-axis. So here's the x-axis, and we're going to flip this blue triangle, because there's no primes next to it, to this pink triangle. So how would we flip to the other side? Well, we want to be the same distance from the line of reflection. So if r is 1, 2 away, we're just going to go 1, 2 to the other side. Q is 2 away, so we're going to go 1, 2. So 2 to the other side, 1, 2. And then P is 1, 2, 3, 4, 5 away. So I'm just going to go to the line of reflection and go 5 to the other side. 1, 2, 3, 4, 5. So we don't need to use our construction tools because we have graph paper and we could just count. So it just flips each point the same distance to the other side, and it's perpendicular to the line of reflection. So the line of reflection was straight across, so we're just going straight down. So for example, if I wanted to reflect across the y-axis here, right, the y-axis is straight up and down. So I want to go straight left and right. And C is 1, 2, 3, 4 away, so I'm going to go 1, 2, 3, 4 to the other side. There is C prime. A prime is 1, 2, 3, 4, 5, 6 away, so I'm going to go 6 to the other side. There's A prime. And then B prime is 3 away, so 1, 2, 3 to the other side. And if we do that, we could use the segment tool to make our triangle a little better. We can flip that triangle over the y-axis just by counting how far from the line of reflection and going the same distance to the other side. Pretty easy for like y-axis, x-axis, or horizontal and vertical lines. So thinking about maybe a rule, right? So if I had a point, let's say 5, 7, the reflection is negative 5, 7. 3, 7, it's negative 3, 7. 1, 7, negative 1, 7. So all that's happening is you're taking your coordinates, x, y, and you're just changing the x value. You're just making it negative. You're flipping it to the other side. So when we flip over the y-axis, the x value is negative, right? We're just flipping it over. I like to count, but this rule also works, so I wanted you to see both. And then basically we practiced in class. The only thing that's a little tricky is what do you do with a diagonal? Because I got to be perpendicular to this line. I don't want to go straight across because that's not perpendicular to the line of reflection. So let's look at point C. If I went 2 up, perpendicular, I should go 2 over. This is where it would be. That's a flip to the other side, where that's the perpendicular bisector, like we talked about yesterday. So C prime would go here. So we actually got to change directions when it's diagonal. So B is 1, 2, 3, 4 from the line of reflection. So I'm not going to go 4 over here. I'm going to go 4 up. 1, 2, 3, 4. So it would flip there. That is perpendicular bisector. So the diagonal's tough because you got to change direction to make sure it's perpendicular. So A, you could go count left, you could count up to the line of reflection. I'll count up. 1, 2, 3, 4, 5, 6. So I'm going to go 1, 2, 3, 4, 5, 6 to the left. So there's A prime. And if we made this triangle, yes, this is flipping over that red line. So that's the tougher one, the diagonals. So just wanted to show you that. If you want to watch it again, you can. But point A prime would be right and left 0, up 8. Oh, head typing. 0, 8. Then B prime would be left 1, up 5. So negative 1, 5, just the coordinates, just so you could see that, you could check your work. And C prime is right 2, up 6. Alright, so try that cooldown. It looks like this. What are the coordinates of this point when we reflect it? It's at 3, 1. What is it here? Give it a try. Good luck.